us learned some biology in school. And one of the fundamental things we learned in school about biology is about the cell being the very unit of life, the basic unit of life. Okay, we know that cells performing the same function are called tissues, tissues performing the same functions are called organs, organs performing the same functions are called system. Today we're going to look at what happens at the level of the cell. This lecture is going to take us into the basics of oxidative stress chemistry, or the chemistry of oxidative stress. Okay, for those of us that use oxygen, I believe everybody knows that we use oxygen. We are called aerobic organisms, and that means that we use oxygen. Now, one of the things that happens to oxygen in us is that it gets converted to what we call the superoxide anion. Right. Now, the superoxide anion is produced because we use oxygen, like I said. Okay, but because we use oxygen, something happens. Nature has given unto us an enzyme called SOD, and SOD simply means superoxide dismutase. A superoxide dismutase comes to convert this superoxide anion to a compound called hydrogen peroxide. Okay, now this hydrogen peroxide can be converted by what is called Fenton reaction to hydroxyl radical. Please go with me and I won't bore you. Okay, now we have superoxide anion, we have hydrogen peroxide. Now, if hydrogen peroxide and superoxide anion bioaccumulate, they can interact to also form hydroxyl radical. This is by what we call Haber-Weiss reaction. So, what's happening here? If superoxide anion gets converted to hydrogen peroxide, and somehow we have a situation where there's an accumulation of superoxide anion and hydrogen peroxide, by Haber-Weiss reaction, it can be converted to hydroxyl radical. Please permit me to take my hydroxyl radical down for a reason. So, by Fenton reaction, hydrogen peroxide is converted to hydroxyl radical. Same thing happens by Haber-Weiss reaction. But to prevent this from happening, nature has empowered us with some other enzyme systems. So there's an enzyme called catalase that helps to convert hydrogen peroxide to water and oxygen. Alright, now the whole idea of this enzyme is to ensure that hydrogen peroxide does not accumulate in the cell to the point where by Fenton reaction it is converted to hydroxyl radical. The essence of the SOD is to ensure that superoxide anion does not bioaccumulate in the cell to the point where it now sees a bioaccumulated hydrogen peroxide to work together to form the hydroxyl radical. Now, why is it that nature has designed us in a manner that this hydroxyl radical is being avoided? The formation of hydroxyl radical is actually the primer for cellular damage. What happens? Hydroxyl radical will attack cells, the lipids in the cells, and convert them to lipid peroxides. Now, once this is done, the membrane of the cell becomes compromised. You know that animal cells have cell membranes, and these cell membranes, the real core inside there is hydrophobic, and the outside and the inside are hydrophilic. So once this hydrophobic core, the lipids that are there become peroxidized, what happens is that this membrane, instead of being a semi-permeable membrane, begins to lose its most unique and most important nature and function, which is the semi-permeability. And so, what nature has also done again is to ensure that in between here, where the hydroxyl radical is attacking the membranes and also going inside to attack what we call macromolecules or cellular biomolecules, what happens is that in here, there's another intervention. This is glutathione in the reduced form, okay, coming here to form the oxidized glutathione, okay. In between here is what we call glutathione peroxidase. So what is happening at this stage is essentially that these peroxidized lipids of the cell membrane are converted back to lipids, okay, and then the glutathione gets peroxidated and then gets oxidized and gets, so here we have another enzyme called glutathione peroxidase and another enzyme in this place called glutathione reductase, okay, and the glutathione reductase using NADPH is able to convert oxidized glutathione back to reduced glutathione, and this glutathione continues. Now if you look carefully at what we have drawn here, you will discover, okay, that this entire thing can be looked at from two ends or from two spaces. What is happening up here is essentially prevention, and what is happening down here is essentially repair. Now, what PB has done is that at the level of prevention, PB has made products that contain catalase, contain SOD, to ensure that at the level of prevention, the cells are optimized. And then we could have a situation where there is already damage. PB has also ensured that you have the glutathione peroxidase as a part of the product to help in the repair interplay. And that is why one amazing thing about this company is that almost all the products has got this integrated into them. We have catalase, we have superior dismutase, and top of it all, we still have the glutathione redox system. That's exactly what happens here. It's a redox system, basically for repair. All right, now we've been talking about the hydroxy radical. This hydroxy radical here is the main player in oxidative stress. What exactly is oxidative stress? Oxidative stress is the state that the cell finds itself when all of the preventive activities and the repair activities are overwhelmed by the outpour or the rate of production of the reactive oxygen species and the free radicals. So we say it's a point we reach, let's just assume, when you have the attackers outweighing the soldiers that are guarding the house. That exactly is oxidative stress. And oxidative stress has been directly linked to almost every health issue and their complications. You see why this is so important, and it's an interesting thing that the company thought about this in producing that flagship product and the other products of PB. If you've not heard this, now you have heard it. What are you going to do about this information?